Welcome back. Why did the thief jump into the shower? So you could make a clean getaway. Okay, I got another one. Okay. Today we are talking about relative frequency. Okay, now relative frequency is just a fancy word for probability, but it's experimental. Okay, so I'll explain what that means in a moment. Um, it's based on recorded results. It's not based on theory. It's based on we do an experiment or we record some results, and then relative frequency is the probability based off that. Now, if I was to talk about, let's say, the weather, um, the next day, or let's say tomorrow, could either be sunny or rainy. And so theoretically, it could be 50-50 either way. Right? Because there's two options. It's either going to rain or it's going to be sunny. So theoretically, it's 50% chance for each. Whereas if we talk about realistically, or if I do an experiment, maybe we'll find that 80% of the days are sunny and only 20% of the days are rainy. So again, relative frequency is just kind of, it's within the realm of probability. We still calculate it the same way. It's just one is based on recorded results. Okay. Hopefully that makes sense. Just please, this formula here, we'll touch on it again in the next lesson, but this is the only formula you'll need to know for probability, whether you are in standard, numeracy, advanced, extension 1, extension 2, not that you do probability, but this is your formula that you will need. So write this down and remember it. Your probability is always given by, and that hash means number of. So we count the number of favorable outcomes and we divide it by the number of total outcomes. Okay. So that's how we'll find each of these probabilities. Now let's kind of go through here. And I've done a little bit of a cheeky example. So Mr. K, it's me. And again, this is relative frequency because this is based off, based off, what did we say it was? Recorded results. Okay. So let's say Mr. K surveys and finds that 25 students complete the required work. 4 students do complete extra. So they do the required plus extra. And then 11 students don't complete the work. So find the probability that a student does not complete the work. Well, again, the probability of that. And normally what we do is we write P of E or P of an event. Or if our event here is here, I'll start writing it in the formal notation. So P bracket complete work, not complete. Okay, so probability of someone not completing. So that's just what this P bracket means. Now, how many people, how many students do not complete the work? Well, there's 11. So that again is the number of favorable students that we're looking for. It's the things that we're looking for. Now it's over the number of total students. So how many students are there all together? Well, I'm going to have to add all these up together because there's 25 plus 4 plus 11. Okay. So that means here it's going to be 11 out of 40. Okay. And that is it. Okay. That means 11 out of 40 students do not complete the work. That's it. Okay. Now with these questions, they might start to get a little bit cheeky. Find the probability that a student does enough work. And so what I need to figure out is the people that do extra, they definitely do enough. And the people that complete it, that's definitely enough. So that means how many students do enough work? Well, there's 25 plus 4, which is a total of P, all right, P probability of enough work. There's the 4 plus 25, which is that. And then we remember from the last one, there's a total of 40 students. So this just becomes 29 on 40. And that there is my probability that a student does enough work. Okay, just a little side note, if I wanted to find it as a percentage, you take your fraction and you multiply it by 100. Okay, but in this case here, a fraction is more than good enough for me. I think that's it. Nice and short. Hopefully that makes sense. Catch you in the next one.